Hi folks, we're going to take a look at number 6 from lesson 5. So the question here says that we have a triangular garden with these side lengths given, and they want to know if 400 meters squared of fertilizer is going to be enough to cover the garden. All right, so let's start by drawing a diagram here. So there's a triangle, and again, here this looks to be the shortest side, so I'll call this 18. This second shortest or second longest, so 21. And this here looks to be the longest side, so 27. All right. And what we want to know is whether 400 meters squared of fertilizer will be enough. In other words, what we need to do is see if the area of this triangle is less than or equal to 400 meters squared. Okay, if it's less than or equal to, means there's enough. If it's greater than 400, not enough. So in order to find the area of this triangle, we're going to need the base and the height. Now we can use any base, any height. So since I've got this one already, almost horizontal, I'll use this as the base of my triangle, which means that this length here is going to be the height. All right, so our goal is to find the height of this triangle. And I see that this height is part of either this right angle triangle or this right angle triangle. And what's nice about each of those right angle triangles is I know one side length in each. I know the hypotenuse in each. And so if I can find either the other side length or one of the angles in these right angle triangles, I can solve for h. And I think what's easiest to do is to find one of the angles. So I'm going to find this angle here, which is part of both the right angle triangle and the larger triangle. And I could do that because knowing all three sides, I can use the cosine law to find the angle. All right, so let's apply the cosine law here. So since I've placed my angle here, I'm going to work with this opposite side of 21. So we have 21 squared equals the sum of the squares of the other two sides. So 18 squared plus 27 squared minus 2 times the product of the other two sides. So 18 times 27 times cosine of the angle, which I'm looking for. And so now it's just a matter of solving this here. All right, so what I'm looking for is theta. Okay, now if you need to write these individual steps, that's perfectly fine. But over time, it'd be nice if you could get used to just isolating in one shot. Okay, so the first thing I need to do is take these two numbers and bring them to the other side. So I'm going to have a 21 squared, and I'm going to be subtracting 18 squared, subtracting a 27 squared. Okay, now I'm doing this division sign because once I've gotten rid of these two things, the next thing I have to do is divide out the coefficient to the cos theta. And don't forget the negative here, it's still there. So now I'm going to divide both sides by -2 times 18 times 27. Okay, and then the last thing I'm going to be left with is cos theta. So I know that the opposite operation is just inverse cosine. All right, so there we go. In one shot, I was able to isolate for theta. So let's see what that's equal to, or at least approximately equal to. So here we've got inverse cosine of, and again, doing this correctly is about using the brackets correctly. So I'm going to open up brackets for the numerator, which is 21 squared minus 18 squared minus 27 squared. Okay, close the brackets for the numerator, divided by, open the brackets by for the denominator, -2 times 18 times 27. Close off the two brackets, and we have 50.977. So I'll just keep that as 51. Okay, because if I try to go to two decimal places, it still rounds up. Okay. So let's go here. So I'll make this 51 degrees. All right, but now that I have this angle, I can use it to calculate the height. So the height is the opposite side. The 18 is the hypotenuse, so I'm going to use sine here. So we have that sine of theta, which is 51 degrees, is equal to the height divided by the hypotenuse. So that means h is equal to 18 times sine of 51. And let's get that here. So let's take, I should do sine of the answer, if you have that on your calculator. Okay, times 18, which is equal to 13.98. So I'll just keep 14 there. 14 meters, and now we can use this to find the area of the triangle. So the area of the triangle is going to be 1/2 times the base, which was this length here, 27, times the height, which is what we just found, which is 14, and that's equal to, so here we've got 0.5 times 27 times 14, which is 189 meters squared, so we have more than enough. So yes, there is enough. There we go. Let's get rid of that email I just got. There is enough fertilizer. In fact, there's enough to cover it twice. So I don't even need to buy an extra bag of fertilizer for the next time I need to use it. All right, so let's recap what we have. So first of all, I got myself a good drawing so that I could set myself up. I realized that I needed to find the height of this triangle, and what would allow me to find that was to determine any one of the angles. In this case here, I needed this angle here, and I could then use my primary trig ratios, in this case here sine, to determine the height. Then I found the area and compared to what we were given, which was 400 meters squared. Okay, that's it for this one.